Good morning, everyone. So, my name is Kathleen Suncados, and I will be the next reporter for the groundwater storage, hydraulics of flow groundwater. So, the topic that I will discuss to you is that uh, the saturated zone and what in each category. So, first, let us identify what is a saturated zone. So, the zone of saturation is the ground immediately below the water table. The pores and fractures in soils and rocks are saturated with water. The zone of saturation is less corrosive than the unsaturated zone above the water table. The moisture content in the region is at one extreme while the other extreme is in the dry soil. Maximum corrosion occurs at the immediate of the two extremes of soil moisture content, also known as the phreatic zone. The zone of saturation can be found anywhere between a few feet to over 1,000 feet below the surface. So, diri sa saturation zone, diri sad ang ginakuhaan og fresh drinking water that can be accessed from spring, rivers, and wells. This water is sometimes polluted by human activities like the use of fertilizers and pesticides, septic tanks, and landfills. So there are four categories of saturated zone, which are aquifer, aquiclods, aquifage, and aquitards. So the first one is aquifer. An aquifer is a layer of porous substrates that contain and transmit groundwater. An aquifer is an underground layer of water-bearing, permeable rock on unconsolidated materials such as gravel, sands, or silts, from which groundwater can be extracted using a water wheel. Aquifer may occur at a various depth. So, ang aquifers daw is a layer which can contain or store water and transmit water or let it easily flow in and out of the aquifer using the water wheel. So, an aquifer is a body of rock and or sediments that holds groundwater. So, groundwater is the word used to describe precipitation that has infiltrated the soil beyond the surface and collected in empty space underground. Aquifers are made up of materials that contains interconnected space. These spaces are essential as they can both store water and let it easily flow in and out of the aquifers. So, ang aquifer, so the opposite of aquifer is the confining unit. The materials of confining units such as clays have poor porosity and permeability that will restrict or prevent the flow of groundwater. So, the layer of clays and other low permeability materials act as the barrier for groundwater flow and may separate aquifer system. However, the water may still pass through this layer but much more slowly than through the aquifer. So, pag iagi siya og confining unit is hina ang dagan sa water. Pero pag sa water wheel nagikan sa aquifer is kusog ang flow sa groundwater. So, the most aquifers falls into one of two types. Unconfined or open aquifers are directly connected in Earth's surface. In contrast, Confined or closed aquifers are separated from surrounding rock layers by confining units above and below the aquifers. So, sa unconfined aquifers are sometimes also called water table or phreatic aquifer because their upper body is the water table. When water can flow directly between the surface, the saturated zone of an aquifer, the aquifer is unconfined. The deeper part of unconfined aquifers are usually more saturated since gravity causes water to flow downward. Open or confined aquifers are supplied by water that filters down from the land surface. It is much like pouring water into a beaker or gravel. Sumura siya kanang beaker, tapos butangan nimo siya og kanang mga rocks. Then ang pag-pour nimo sa water mao na ang example sa unconfined aquifers. Mao na ang example sa process kung giunsa ang unconfined aquifers. The water easily flows between the grains and the level of water in the beaker is depend upon the water supply. The water table represent the upper surface of unconfined aquifer. The position of the water may vary due to the greater the water supply, the higher the elevation of the water table. We expect that the water table is to show some short-term fluctuations related to storm and longer-term seasonal variation. Water doesn't enter confined aquifer as easily as it does as an unconfined aquifer. The overlying confined layers prevent water from flowing directly into the confined aquifer from above. So the precipitation results in water flowing down through soil, rocks, into the upper unconfined aquifer, only to be blocked by underlying confining layer. So, sa confined aquifer, a water-bearing subsurface stratum that is bounded above and below the formations of impermeable or relatively impermeable soil or rock, also known as the artesian aquifer. So, sa confined or closed aquifer, the overlying confining layers prevent water from flowing directly into the confined aquifer from above. So ang groundwater is dili siya hinay ang pag-flow sa tubig kay naga prevent ang confining unit. So the precipitation result in water flowing down through rock into the upper unconfined aquifer, only to be blocked by underlying confining layer. So ginablock ang tubig sa confining layer. Groundwater in the confined aquifers is under pressure and the flow to the surface through artesian wells with little or no pumping needed. Properties of aquifer. Porosity. So, the porosity of a rock or soil is simply its property of containing interstices. It can be expressed quantitatively as the ratio of the volume of interstices to the total volume, and may be expressed as the decimal fraction or as a percentage. So, ang porosity daw ay measure kung how much space in between rocks. It is taken to be the ratio of the volume of empty space or pores in a rock to its total volume, and it is often expressed in terms of fraction or a percentage. Since fluid can occupy this free space between rocks, porosity is also measurement of how much fluid that rocks can hold. So sa porosity is kanang sand god is nagtapok ang mga rocks. So dili man nato mabalaan no kung nagdikit ba sila or naglagyo. So ang space between rock sa isa ka rock ug sa isa ka rock mao na ang ginatawag na porosity. Mao na ang ato ang i-identify. So next, there are two types of porosity. Primary porosity comprises the original interstices created when a rock or soil was formed in its present states. In soil or sedimentary rock, the primary interstices are the space between grains or pebbles. In intrusive igneous rocks, the few primary interstices result from cooling or crystallization. Intrusive igneous rocks may have large opening and high porosity resulting from the expansion of gas, but the openings may or may not be connected. Metamorphism of igneous or sedimentary rock generally reduce the primary porosity and may virtually obliterated it. So primary porosity describes the pore space between grains that are formed during depositional processes such as sedimentation or diagenesis. Fractures such as joints, faults, and opening along planes of beddings or schistosity in consolidated rocks having low primary porosity and permeability may afford appreciable secondary porosity. In some rocks, such as secondary porosity, affords that only mean that for the storage and movement of groundwater. Solution of carbonate rock, such as limestone or dolomite, by water containing dissolved carbon dioxide takes place mainly along joints and bedding planes and may greatly increase the secondary porosity. Similarly, solution of gypsums or anhydrite by water alone may greatly increase the secondary porosity. So secondary porosity is formed from post-depositional process such as dissolution, precipitation, and fracturing. Fractures, roots, channels, and animals' burrows are some examples of secondary porosity. Total porosity is the sum of the primary and the secondary porosity. Water yielding and retaining capacity of unconfined aquifers. Specific yield is clearly an important factor in water availability and is the factor that is used to convert saturated thickness to the actual volume of groundwater available. So the formula is volume equals area times saturated thickness or ST times specific yield or SY. So specific yield is the water removed from unit volume of aquifer by pumping or draining or drainage, and it is expressed as percentage volume of aquifer. Specific yields depends upon grain size, shape, and distribution of pores, and compaction of the formation. The value of specific yields for aquifer are in the range of 10 to 20%, and for uniform sands about 30%. Field capacity is the amount of soil moisture or water content held in soil after excess water has drained away. The physical definition of field capacity is the bulk water content retained in soil. So, field capacity is a measurement that has to do with the ability of soil in a given area to absorb water. Once all exceed and surface water has been drained from the sea. Specific retention. The ratio of the volume of water that a given body of rock or soil will hold against the pull of gravity to the volume of the body itself. It is usually expressed as a percentage. So, specific retention is the ratio of the undrained water to the total water in a rock. The undrained water being water contained in a rock void or pore spaces, from which it cannot be recovered by drainage or pumping. It is retained against the action of gravity by molecular attraction and capillarity. Next is permeability. So, the permeability of a rock or soil is a measure of its ability to transmit fluid, such as water. Under a hydropotential gradient, many earlier workers found that the permeability is approximately proportional to the square of the mean grain diameter. So, permeability daw is a measurement of how easily fluid can flow between rocks. Next is transmiability. Transmiability, a measure of the ratio of the response amplitude of the system in a steady state force of vibration to the extension amplitude. The ratio may be in forces, displacement, velocities, and acceleration. The transmissibility of an unconfined aquifer depends upon the depth of the GWT. So, transmissibility daw is described the ability of the aquifer to transmit throughout its entire saturated thickness. The second category of saturated zone is the aquifluid. It is a solid impermeable area underlying or overlying an aquifer. It is impermeable area overlies the aquifer. Aquifer pressure could cause it to become a confined water. It can be absorb water but cannot transmit it in significant amount. So, aquicloud may be defined as a geological formation of a relatively impermeable material which permits storage of water but it is not capable of transmitting water through it. So, sa aquiclouds daw is kanang ga-transmit lang siya og store siya water but cannot transmit water kay na siya sa pinakailalim, which ang pinakailalim is kanang natabunan na po siya og sand, soil. Next is the aquifluid. So, aquifluid, an impermeable body of rock which contains no interconnected opening or intersects and therefore neither absorb nor transmit water. So, kasabot naman tanong what is unsa ang aquifluid, dili siya maka-store og water, dili siya maka-absorb og water, o dili po siya maka-transmit og water. So, Aquitards. A bed of low permeability adjacent to an aquifer may serve as a storage unit of groundwater, although it does not yield water readily. So sa Aquitard, it is a geological formation of poor permeability, but through which seepage is possible, and hence it would yield water freely to a well. And lastly, the Dorsis Law. Dorsis Law is a simply proportional relationship between the instantaneous discharge rate through a porous medium, the viscosity of the fluid, and the pressure drop over a given distance. Dorsis Law is only valid for slow and viscous flow. The formula is Q equals to TIW, where I is the hydraulic gradients, W is the width of the aquifer, and T is the coefficient of transmissibility of the aquifer. So Dorsis Law is an empirical relationship for liquid flow through a porous medium. A common application is groundwater flow through an aquifer. It gives the relationship among the flow rate of the groundwater, the cross-sectional area of the aquifer perpendicular to the flow, and the hydraulic gradient, and the hydraulic conductivity of the aquifer. So that's all. Thank you.